Assalamu alaikum, everyone. Good evening. Uh, Jazakumullah khairan for attending today. So, what we presented by far, and we can start. What we presented by far is that in the first session, it was about Python. Okay, Python itself. In the second one, it was about three libraries in Python. It's NumPy, Pandas, and Matplotlib. These libraries are, the main libraries in data science. You will use them quite a lot. Okay. And in this session, what we will do is that we will try to use the thing that we learned in NumPy, Pandas, and Matplotlib in a real data set. Okay. So why do we need all these tools in Pandas? And we will learn a bit about something also called Scikit-learn. It's a fourth library that you will actually meet a lot through your learning journey with AI. Okay. So I guess you can start. Okay. It's not too long. I think it's only one data set that we will cover, and I'll leave the other one as an exercise. Uh, so yeah, let's start. طيب, in the first part, actually, you can see that we put all the imports in the same place. Previously, we were actually importing the library when we need it. Okay, you will see that in the previous lecture, we just imported NumPy, then used NumPy in the next line. Okay, but usually you see that
Processing.
we import
Processing.
actually all the libraries. Okay, uh,
Level it coder.
just a second.
One hot intro.
We actually import all the libraries at the beginning, then we use them throughout our work. So here you can see that we imported NumPy, Pandas, Matplotlib, and something called Scikit-learn. So what is Scikit-learn? Firstly, we said that NumPy is for handling the arrays, right? And we said that Pandas is actually built on NumPy, and it's used and it's like an improved version of NumPy, and it handles something called data frames or the tables. It's arrays, but in addition to that, we have the indices and we have the column names. Okay, columns names. And we said that Matplotlib, okay, use it for the plots, and we have Scikit-learn. Scikit-learn actually used for several things. Firstly, the pre-processing. What do you mean by pre-processing? Actually, pre is like before, then processing the data before something. Okay. So what is this something? This something is actually the AI model, okay, the machine learning model. So actually, in order to take a data and input it into an AI model, you should do some pre-processing. This pre-processing includes several things. We will talk about them throughout this notebook. Okay. In addition to the pre-processing, this Scikit-learn has the models themselves. Okay, the AI models actually exist in the Scikit-learn, so we will use it, but not now. Okay, now we are just doing the pre-processing in this notebook, but we will use it in the next lecture, next lectures, inshallah. Okay, there are actually quite a lot of other things here. There's something called metrics. Okay, it's like if I want to evaluate my model, how I know my AI model is good or not. Okay, like the accuracy. Okay, if my model achieves accuracy of 90%, for example, then it's good. For example, it might be good, it might be not, but maybe it's good if it achieved the high accuracy. Okay, so this accuracy is called the metric. Okay, there are quite a lot of metrics, and all of them you will find them in Scikit-learn. Okay, and there's something also in the Scikit-learn. It is the data splitting. Okay, uh, if I want to, we will encounter this also throughout the course, but if I want to split the data into something called train and test, where I will use my AI model, train it on the train part, then evaluate it and calculate the accuracy on the test part. This is what happens. Okay. Uh, if I want to do the data splitting itself, how should I do that? There are ready functions already exist in Scikit-learn. Okay. Uh, so that's it for actually these three bars are very easy. Alas, it's like the models themselves are actually just three lines. You define the model, fit, predict. Okay, and for the metric, it's just one line. You can just import it from Scikit-learn like this, from Scikit-learn. Okay, from metrics, for example, import the accuracy score. Okay, then in the accuracy, you will later just give it predictions and labels or the ground truth. We will encounter this later, but it's very, very easy to use. Okay. Uh, Also, there is splitting. If you remember, we did something like split into train and test in the previous lecture. Okay, so here it makes it actually very easy, and you will discover that there are actually uh more complex types of data splitting that actually works better in reality. Okay, we encounter something called Trent's split. Okay, later we will see something called k-fold. Okay, there are some variants of k-folds like stratified k-fold. Okay, and it's not important. All of this will be covered, inshallah, when we start the machine learning part, which is maybe the next lecture or the one after it. But for now, we will talk about the pre-processing. Actually, you will find out that in any AI model, okay, the pre-processing part is actually 90% of the notebook, okay, and all these parts is actually just the 10%, the last 10% in the notebook. Okay, so the whole work actually is here. Okay, these things are somehow fixed. Okay, but the real work usually in the data actually it's about how do you pre-process your data and prepare it well for the model. Okay, so in this notebook we will just talk about this part. So when we talk about pre-processing, okay, what do you mean by pre-processing? Pre-processing just means preparing, okay, the data to be entered into the model or a machine learning model or AI model. Okay, so what do we mean by preparing the data? What preparations we should do? Okay, so just we will find that out throughout this notebook. But firstly, no machine learning model could process text. Okay, they cannot process the text itself. You should convert this text into numbers. Okay, this is called encoding. There are many types of encoding. We will encounter it, inshallah, in this notebook. Okay, and not only encoding, but uh, you will find that actually there is, if you remember in statistics, there is something called z-score, right? Do you remember it in statistics? It's like if I have values that actually, regardless of their range, okay, maybe there are prices of houses that actually round from 100,000 to 200,000, for example, okay. What z-score does is actually something called standardization. Standardization means that I want to convert the range of the column of the columns. Sometimes you call them features. Okay, so what z-score or standardization generally do is that I want to convert the range of this column, regardless of what is this range, into a much smaller range. For example, if I use z-score, most likely it will be between -3 and +3. Okay, there's something called min-max scalar, which converts between 0 and 1. Okay, so why this is important? Because you will find out that actually the machine learning models or the AI models, okay, if they have columns that actually have very different ranges, if these columns have very different ranges, okay, then the model will do very badly. Okay, so they say that all the columns or the features, you call them the columns, you call them features, all the columns should have the same range to the best possible, okay, to whatever it's possible. Just make the range very close to each other, okay, and you will get significantly better results. Why? We will find that in the next lecture, not now, but we have standardization. Okay, so you will find mostly these are the main parts. In every data set, you should do this too. Okay, with its machine learning, with its deep learning, there are some actually optional things. Not really optional, but something called imputation. Okay, imputation means what? Means filling the missing values. Okay, sometimes you will find out that if you have a data, uh, if you have a data set that has missing values, okay, and you actually input it into a model, you will get an error because the model cannot handle missing values. Missing values like what? Like if you have a survey now, okay, and there is some of the respondents who actually respond, there is a field that is optional, okay. For example, it's the age, okay, and this the one who actually filled this survey didn't fill that part, okay. So you have the data, the values for all the values for this guy, okay, but not the age. Okay, so this is considered a missing value. Okay, so how you fill it? If you want to input this data into a machine learning model or AI model, you should fill this value with something. I don't know what is it, but you should fill it with something. Okay, so what should I fill it with? Maybe just a random value? Not really an option. Okay, maybe just zero. maybe, maybe not. لا, but I don't think it's a good idea. But what do you think about filling it with the mean? Okay. يعني if you spread your survey throughout the university, okay, most likely the students of the university have a specific range for the age, right? Maybe between, I don't know, 18 and 24 or something, يعني, okay? So if that's correct, and you know actually that all the respondents are actually in this range of age, maybe the mean, filling the missing values with the mean is a good idea, right? Uh, but imagine this. Imagine that the field that you try to fill is actually not a number, not like the age, okay? But like the college, for example, okay? Is it the computer science college, the Sharia college, okay? So mean doesn't make sense here, right? You have categories, يعني. How do you take the mean of the Sharia and Hasib and okay? So what you do is maybe using the mod. Okay, do you remember the mod? The most common value. Okay, so maybe if most of the respondents are actually from the computer science college, okay, then it's a good idea just to fill all the missing values with the computer science. It's not the most accurate يعني thing I can do, but it's actually make the machine learning model work. Okay, I can input the data fully into the machine learning model and it will learn something useful. Okay, so one sample doesn't affect really the model significantly, يعني, or if the percentage of the missing is small. Okay, so even filling this missing values actually is somehow of an art. Okay, you should understand your problem, you should understand why these values are actually missing, and try to fill them with some يعني reasonable values. Okay, so maybe these are the things that we will encounter now. So let's go throughout the notebook. Okay, so you'll see now that we have imported everything here. Okay, they can comment this. From sklearn, there is something called preprocessing, where you can see that we have the standard scaler. Standard scaler is just the z-score. Okay, this I just apply the z-score to the feature of the column, and you have something. This is the encoder. We have something called label encoder. Okay, and one hot encoder. We'll explain them inshallah next. Okay, and there's sklearn.impute, and there's something called simple imputer. Simple imputer is just for filling the missing values. Okay, but يعني it's too complex to use. Wallah, it's not complex to use. It's actually one line, but يعني if you have a data frame in pandas and you want just to fill the missing values, okay, there's a function called fillna. Fill na mean the mean يعني the missings. Okay, we call them na fill in pandas. So you can literally just do it like this. Okay, so please go to all the missing values in this data frame, okay, and fill them with the mean, okay, of this data frame, this يعني table, okay, and make in place equal true. In place equal true means that I don't want to put df equal df dot fillna. If I don't have this, I should put it like this. Okay, so we will encounter it, but يعني it's very easy stuff, يعني, inshallah. Okay, so these are the libraries. This is the data we will use. Okay, where's the data? I don't know. Let me try and run it. Let's check. But you can see that we have pandas, okay, read CSV. So the data is actually a CSV file. So he is giving it a path here, okay, content train CSV. Yani this path supposed to be in the same place as the notebook, or at least yani this path should actually be directed towards the CSV file. Where are you saving the CSV file? Okay, so when I just ran this one, notice the error here, file not found. Okay, and he put the arrow on this line, so there's a problem here. No such file or directory. Okay, where should I upload the file? So it depends on the environment you are using. If you are using your own computer and you are running this code on your computer, for example, in Visual Studio or something, okay, you should just put the CSV file in the same directory as the notebook. Where is the notebook? Just put the CSV file with it and just read it like this. Okay, just write the name and CSV. Okay, but here in Colab, okay, they have this this tab at the left. You see files, right? If you look into files, this part, okay, you can actually upload the dataset here. So I'll now just catch up the data. I have it somewhere here, yeah, and just put it here. If you see the arrow, I'm not sure. So I'll just put it here, and it will upload it here. Okay, so this is the dataset I'm using here. I brought it from somewhere. I don't know, but him. Okay, I can just go here and copy the path. Okay, and just use it here. You'll notice it's the same. Okay, so when I run this, it actually worked. Okay, so You can close this now, but you can upload any files from here to the left in order to use it in your code. Okay, even if big data sets. So I just read the data set here and just يعني slightly كده just printed the data set shape. Okay, and the head just give you the top 5, and the shape just give you the shape. So we have 891 samples with 12 columns. So 891 rows and 12 columns. Okay, we usually call them 901 samples, okay, and 12 features. Okay, features, you will find you will hear this word a lot. So we usually when we are talking about columns, we say they are features. Okay, so we have 12 features in this data set. So what are these 12 features? We have the passenger ID, survived, P class, name, sex, age, SIP, SP, barge, ticket, fare, cabin, impart. What is this data? Okay, this data I actually obtained it from Kaggle. It represents something called the Titanic. Okay, the Titanic survivors, or those who actually got into on top of the Titanic, and here who is actually survived or not. Okay, so this is like a machine learning problem that we will do maybe later. Is that could you, based on these features, okay, based on the ticket of this guy, based on how yeah, siblings he has on top of that on top of that ship, his age, his gender, okay, and the name doesn't matter, based on the fare he actually paid, based on the class of his ticket, okay, could you predict whether this guy actually survived the Titanic or not? Okay, so it's a nice problem. Uh, we will try to do that later, the machine learning part, okay? But for now, we should fix these things, yani. You can see the problems here. Firstly, we have a lot of text, okay? All these text should be either dropped or encoded in order to be yani, converted into some numbers that we can later input into the model. The same here for the gender. The age is good, everything is good. The ticket, maybe the fare, no, the fare is good. The cabin, oh my God, you see means what? Means nans. Okay, so we have missing values in the dataset. So we should fill it somehow, okay? Or maybe, I don't know, maybe you should think about how to handle this column. So you can see there are many problems here, okay? The encoding part, the missing values part, maybe even there are some duplicates. Duplicates means that a row is actually repeating several times, and this is actually a problem for the models later, okay? So this is the dataset we'll handle now, okay? So let's try something. Let's try df Titanic dot info. Okay, info will just give you information about the features if you remember. So we have the features here. You can see that all the sums are 891. Okay, and we have 891, 91, 91, 91, 91, 714. So wait a minute, we have some missing values in the age, right? And 204. Oh my God, so we have a lot of missing values in the cabin. Okay, so we should think about filling these missing values in order to use the machine learning model later. Okay, and you can see that we have object, 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 object. What does object mean? It means string. Okay, so these are strings. We should encode them somehow, or drop them, or try to handle it somehow. Okay, so I just try to give you some very interesting intuition about what should I do with each column. Okay, if you want to handle this data to prepare it for a machine learning model, what should I do with these columns? Which encoding should I use? Should I drop this column or just use it? Okay, I can actually drop most of the columns and maybe use only the age to predict the survival. Okay, I can do that, but no one said the results would be good. Okay, so how could I know the best approach actually to pre-process this data? Okay, it's I'll try to give you some intuition, but generally the rule is that unless you tried actually every idea you have in mind and you saw the accuracy by yourself, whether it's improving or not, whether it's decreasing or improving, you cannot decide whether your idea is correct or not. Okay, so how do you know if what you are doing is correct or not? You will do that only based on the accuracy you are getting from the model. Okay, but you have some intuition at the beginning that tells you generally what should work, what shouldn't work. Okay, so what is this intuition? How do I know how to process this data? So the intuition is basically how you as a human actually think about this problem. Okay, so Imagine this. Forget about AI totally, okay? And let me ask you a question. You as a human, okay? If I ask you based on this dataset, try to utilize the information you are seeing in this table, okay, to predict whether this guy has survived or not, okay? If I ask you as a human, forget about AI, as a human, just to, based on these data, to predict the survival of this guy, which of these columns would be useful for you? Okay, the passenger ID, does it matter? يعني whether this passenger is the first, the second, the third, does this matter? It doesn't, right? No. Okay, so what does that tell you is that most likely you should drop this column. Okay, you should drop this column. Okay, let's see the P class. It means that the ticket class, is it yani business class, or your ticket, is it business or is it guest? Okay, so does that matter? What do you think? يعني it matters actually. Why matters? Because يعني it's like if you are a business class, most likely you have more safety options. Okay, so this might be a useful feature. Okay, the name. What do you think? Well, like, you say no, okay, but it's mostly no. Okay, if I were to, yani, if it's my first time to see this data, I most likely say no. But if you thought about it slightly more, you can see that Mr., Mrs., okay, most likely, if you dig into this data, you will might see yani, the name of the initials of these guys. Maybe some of these are actually professors, okay? Maybe some of them are actually engineers. Maybe some of them are actually, I don't know, okay? So maybe, but yeah, and the first intuition tells you that you should drop this column as well, okay? The gender, it actually matters, okay? So this matters. The age, yeah, if someone actually is very old or maybe very young, most likely he will not be able to maybe swim. Okay. Allowable. The number of siblings you have. Okay. So if whether you are alone or you have a family, so this matters actually. Okay. I don't know what is this one. Allah يهديك عبد الرحمن, yeah. Uh, the ticket, okay, the ticket number, it doesn't matter. Okay. The fare, I'm not sure. I think this is what they have paid in order to got into this ship. Maybe it matters. Okay, so we'll keep it. Why not? The cabin. Okay, where is this guy? Yeah, he's closer to the exit or not. Okay, so this actually might matter. Okay, in part, I think at which port, okay, you actually got onto the ship. I'm not sure if it is useful or not. So actually, if you are not sure about something whether it's useful or not, just keep it. Okay, and you run the model later, get the accuracy, okay, and then try to go back and remove that column, okay. If it actually improves the result after removal, okay, then most likely it's useless, okay. But if it decreases the accuracy, then you should return it back, okay. So we just agreed on the features we are about to use, yani, okay. But let me tell you the problem. We said that we want to use the edge. It actually matters, right? And we said the cabin, whether this guy is close to the exit or not. But oh my God. Remember here that the age has, yeah, and some missing values. This is acceptable, but the cabin, oof. Okay. Most of the data is already actually missing for the cabin. So for most of the passengers, we don't know where were they, okay, when they were on top of the ship. Okay. So this is actually a problem. Having such amount of missing values, okay, you will actually try to fill it with the mean, for example, or the mod, okay. But then you will see the accuracy. If it's getting better, okay, then okay, yeah, or see the accuracy and just record it, then remove this column, okay. If it actually give you good results after removal, then yeah, the amount of this missing values actually harmed the model, okay, to the extent that made this feature useless, okay. So what I told you is just the first intuition is just tells you what is useful, what's not, okay, and then there are some other things that actually affect your decision about removing columns or not, okay, for example, like the missing values. But let's just go with it like this, okay. So uh we said this is the data, okay. There is describe, okay. We can see that this describe for, yani, does the mean, median, and mean matter for the passenger ID? What do you think? uh absolutely no. So this is useless. So for the survive, the target doesn't matter, okay, because it's just 0 and 1, okay. The age, it matters نوعا ما. You can see that the minimum is 0.48, 0.42. So we have babies in this list, okay, and we have 80, okay, so we have some old guys. But this just helps you understand the data better, okay. So what we are doing now is something called exploratory data analysis. It's like I want to explore the data in order to understand what I have at hand, okay, and how should I handle it. Okay, so in the sibling spot, see that most of the minimum is 0, okay, the median is 0, the third quartile is ربيع المدري ال 75 is 1, okay, but the max is 8. Could anyone, okay, figure out what does this column tell you? There's an important information here in this column, okay. Not only this column, أيوة الله يفتح عليك يا أخي. There are outliers in this column, okay. Given that you see the minimum is 0, the first quartile is 0, the median is 0, okay, and the third quartile is 1, and the maximum is 8. There are some outliers, okay. There are few people who actually brought all of their families along with them on top of Titanic. الله الله يعوضهم مشكلة. So this actually tells you an important for me that there might be some outliers. So should I handle them later? It actually also depends on the same case, the same thing I thought before, is that you will decide all your options based on the score you are getting from the model, okay. You at the beginning, you will see these results, you will have this intuition, okay. So the intuition now tells us that there are outliers, so maybe removing these outliers will help the model. Our intuition tells us that these are the columns that are useful, we chose them before, okay, so maybe that will help better. But you will find in many cases some surprises in the results, okay, something that actually makes sense for you, and it makes 100% sense for you, okay. When you try it, you'll find it decreases accuracy. Okay, and vice versa, okay. So maybe if you use the name, which is absolutely useless here, if you use that, maybe it will give you better results, okay. Actually, that doesn't tell you that the name is actually a useful feature only, but tells you that there is some hidden signal inside the name that you didn't extract it. Similar to what I said before, maybe the initials, okay, maybe the initials matter in predicting or not, okay. So المهم just try to think about this one. Let me tell you what some interesting idea. We said that there are some missing ages here, right? There are some missing ages here. Now look at the name. We said it's useless, right? But see here, we have Mr., we have Mrs., we have Miss, we have Mrs. Okay, these actually might indicate whether this woman is actually old or not, right? married, it could be an indirect signal, okay, whether this woman is actually old or not, okay. So imagine if this sample actually has missing age, okay. So maybe the model actually, when he learned, he actually tried to utilize the age, and when he finds some useless age we will put here, he will try to use the interest signal he are getting from here, maybe, okay. And actually this is, you can try this, maybe you'll get better results, okay. What I'm talking about now is something called feature engineering, okay. When we are talking about something called features engineering, it means that I have a data set, I want to extract better signals from this data set that actually help the model to predict. How do I extract these signals? It's mostly based on your intuition, and there are some actually standard ways to do that, okay. But what we did now is some feature engineering. So there are some interesting cases like this, okay. Sometimes you will get features that actually very useful, that actually improve the performance significantly, okay. Some features that you think are actually useless might be actually useful if you actually handle them appropriately, okay. So it's interesting, right? أنا أشوف صراحة very interesting the preprocessing part. So let's go. We said that there might be some outliers, okay. So you can see that the minimum here in the fair is 0, the first quartile is 7, 14, 31, 512, okay. So there are outliers. So let's continue, okay. This is just to understand our data, and we have some initial sense of everything we have at hand. This is identifying the missing values. Actually, as I mentioned, the simplest part you can do is just info, okay. This will all This will already uh told you about the age. Yeah, you understand. We're gonna والله صراحة هو الحقيقة في كثير اتواصلوا معي طلبوا مني it will be in English. Okay, not everyone actually understand Arabic, unfortunately. And the head of the center actually asked me to make all the lectures in English from this third session. والله so sorry for that. uh, المهم we can continue the identifying the missing values. uh, As I mentioned, you can just use the يعني the simplest possible thing is just .info in order to identify whether there are missing, okay, and how much percentage we have in the missings. But you can GPT some code, okay, to give you the yeah, all the missings. Here it's actually getting the Titanic, getting the dataset data frame we have. Uh, it's try to see how much nulls we have. So maybe I can do that line by line. So this is the dataset, right? This is the dataset, okay? So when button is null, what does that do? It goes to each cell, okay, and classify it to true or false. Is this null? No, 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 yes, okay. Then when it does sum, what happens is that it consider each false as 0 and each true as 1, okay. So it try to sum all the ones here, all the ones here, all the ones here, all the ones here, and thus give you the amount of missing values in this column, okay. So let's see. Yeah, this column 0, this column 0, 0, 0, 0. Age we have 177. Kevin we have 687. In fact, we have 2. Okay, so these are the missing values. So what it does here is that it tries to calculate this amount of missing values. Okay, then normalize them by dividing them by the total length. What does that do is if I did that here, it's like it gives you the percentage. Okay, the percentage of missing values out of each column. So for this one, you have 19% of the samples are actually missing. For this one, you have 77% of the samples are actually missing. Okay. So that's what does it here. Then it defines the data frame and just put this as a column and this another column. Why it does do that? Just because it's easier to plot the data frames. Okay, so he will use the data frame to plot this here. But yeah, you can just take this and just put the bar plot. If you remember the bar plot from the previous lecture, you can just use these ones. Okay, so what he does here is that if the missing values are actually less than is actually greater than 0, I want them. Okay, so notice here he just plotted 3 columns, the columns that has missing values. Okay, so how he filtered all these zeros, what he did here is that go to the missing data frame that we created here. Okay, if the percentage of the missing or the count of the missing is greater than 0, keep it. If you remember, this is the Boolean condition we did before. Okay, if it's greater than 0, keep it, otherwise you will drop everything. So it dropped all the columns except only the age and the cabin and impact. Okay, then please sort these values. Okay, descending. So it's ascending false means descending. So from highest to lowest. So what it does here is that put the cabin first, age second, and then the impact third. Okay. Uh, it's just some fancy stuff to present the outliers in a good way. Then he just printed it. All this from some slop from GPT, alas, but you can see that the main part is here. Just use the bar plot. For the x-axis, use or the names, just use the index or the names. Okay, the names of this. Can see it here. This is the index. Okay, this is the index. So use the index or the name column name as the category. Okay, so we put it as the x, and the y is actually the percentage. Okay, so we can see from this plot that the cabin is 77, age is 23rd or something. So I don't know. It's just feel easier to actually inspect things in figures. I have this plot already, okay, and I have info already, okay. So why do I have to actually plot things in figures? Okay, you will find out that this data is actually simple. We have only 3 columns, 3 columns that had missing values, and the data itself is small, maybe not 800 or something. So, but maybe we are talking about data that has 100 columns. Maybe you're talking about data that has actually 100,000 of samples. Okay, this exists. So such data sets actually exist. Okay, so if you are talking about such amount of data, then usually you'll find that figures are actually easier to handle than values or tables. Okay, So you will find that that's why people prefer to use figures. And sometimes you will see some patterns in the figures that actually not easily seen in the tables. Okay, so this is just the missing values. So here, yani, there are some different strategies that we can do. So for the age, okay, so let me ask you a question. We have the mean, right? You can fill with the mean. We have the median, okay. When should we use this or this one? What do you think? Any ideas? There is some property, okay? Yeah, the outliers. Why? Because the mean actually get affected by the outlier, okay? And the median doesn't affected by the outlier. Okay, this is the intuition we have, okay? This is the intuition we have. So the intuition tells us that if this feature has outliers, then fill it with the median. خلاص. But if it doesn't have outliers, use it the mean. So this is the intuition we have. I repeated that a lot because yeah, it matters. Okay, this is the intuition we have. But is really the median is better? Okay, the real question is that you will decide whether I use the mean or median, not yani, you will try your intuition, okay, and see the score, but you will depend only on the accuracy you are getting in the model. Okay, so you have the intuition that you should use the median, but try the median and see the score. Then go back and try the mean and just see the score. Maybe you will get better scores with the mean. Okay, you have intuition that you will start with. Okay, you will feel it's the correct one. Try it. If it's the correct one, then this is great. Okay, but try to experiment with other things. Okay, not something that totally unreasonable, but yeah, it's something like the mean and median. It matter actually. Okay, sometimes you'll find there are some good results with the mean. Okay, so here we just use our intuition. Okay, so we went to each column, like the Titanic column, the age, okay, and just filled it with the same data set, median. Okay, we use in place equal true, so we don't put the df Titanic clean equal كده. We just يعني easy way to do this. Okay, we went to impact. Impact is actually the port where this passenger actually got on board, يعني on board of the ship. Okay, and for this one, because we are talking about categorical feature, okay? Maybe I didn't mention this before, but we usually call the features that has numbers, numerical features, okay? And the ones that has any text or single object, we call them categorical feature, okay? So the impact is SCS. I think there are 3 categories. And it means actually the port you are yani got on top of the ship yani. So given its category, we usually fill the value with the mod, okay, the most common value. So you can see that here he got to the dataset, got the mod, okay, and use of 0. What does of 0 means? Wait a minute, there is a list here. Are we talking about a list? Yani I assume the median is just a value, right? The mean is just a value, but the mod, we have a list, okay. If you remember in statistics, in one dataset, there could be multiple mods. Okay, there could be multiple mods. So if I have a dataset where, yeah, exactly. If I have a dataset where I have 5 values of A, 6 values of B, 6 values of C. So what is the mod? It is B and C, not only B, not only C. Okay, so there might be some multiple mods. So you will find that the list here, that if you use the mod, the output will be a list. Okay, so we know that in this Titanic data, it's not multimodal. There's only one mod. So we just use of 0. Like usually, maybe you want to build this one, okay, to see. Sorry, I didn't run this one. Maybe you want to run this one. We have only one mod. Okay, so we just use that one. It's S. Okay, and in place equal to, and here we dropped the cabin. Okay, we said it's useful previously, but we dropped it here. Why dropped it here? Because it contains so much missing values. Is it a good idea to drop it? Intuitively, okay, maybe you have a lot of missing values, but in the same time, yeah, Kevin looks very useful, because if he could know where this guy actually where in the ship, it might be whether he's closer to the exit or not. This might be useful actually as a feature for the model, but too much missing values. So you can decide. Okay, I did something here. I'll try it in the model. I suppose to try it in the model. Okay, see the result, then go back, return it back, and maybe fill it with the mod similar to this one. Okay, and try the model again, see if the result is good or not. Okay, you will decide based on the results of your model. Axis equal 1 means column. If it's axis equals 0, then it means row, and we don't have rows. Okay, the rows are actually numbers. Okay, so if you want to drop a column, you will always use axis equal 1. In place equal to, as I mentioned, it's just not to put كده equal كده يعني. Okay, so I just printed the values after running this cell. You see that everything has been filled. Okay, so missing values has been solved. So what is next? Check for duplicates. Okay, I mentioned this before, that duplicates actually matters, significantly matters in the model. Why it matters? Where is the problem if I have actually two passengers with the same yani if this record, this row actually is repeated maybe twice throughout the data or three times throughout the data? Where's the problem? The duplicates problem actually, maybe it's not clear here, but it will be very clear when you train a model, or particularly when you split the data. يعني imagine how do you actually train a model? Actually, we firstly pre-process data, prepare data, okay? Then what we are doing about this prepared data is that we split it, okay? We split it into train and test. Later, we will use machine learning model or AI model, okay? We will train, okay? We will train on the training data, okay? Then we will evaluate the model or calculate the accuracy based on the testing data. This is what happens, okay? Now imagine this. Imagine that we have a specific guy or record in this data that is duplicated 5 times, okay? We didn't know that, and we didn't remove this duplicate. What will happen is that when I split to train and test, maybe this record, okay, maybe 4 of them, okay, will go in the test, and 1 of them will go in the train. Maybe that will happen, okay? Maybe 4 of these, it's the same entry, the same record, the same row. Maybe 4 of them will go into the test, and only 1 of them will go into the train. And oh my God, the model already see 1 sample, okay, in the train that actually exactly match some samples in the test. So we call this thing what? We call this thing leakage. Okay? No, not overfitting. We call it leakage. Leakage is something like what I mentioned now. It's like you are leaking some of the test information into the train information. Okay? When you do something like this is called leakage, and you will find the accuracy, mashallah, Allahumma barik, 100% to 100%. أقول يا أخي خلاص. You splitting the data wrong, okay? The duplicates actually ruined the whole thing, okay? Ruined the whole split. Okay, so it's يعني incredibly important to actually check for the duplicates, okay? So this is called leakage. Overfitting is not is something very, very different. We will discuss it inshallah in the next lecture, but it's different from this one. It's like overfitting means that training with the training data, okay, and getting super good results, but in test you are getting very bad results, okay? This is called somehow overfitting. But leakage is that you are getting super good results in training and super good results in testing, but you are not aware that you are leaking some information from the test into the train. You trained on some of the test information, okay? Getting good results in train and test is a good is a good thing, okay? But knowing whether this result is actually a result of a leakage or a good result, يعني a good model, this is important for you to do in your data analysis, يعني, okay? You should ensure that the pre-processing you are doing is leakage free, okay? Leakage actually has many forms. What I mentioned now is one form, and that's why, but it's the most important one, okay? Sometimes leakage could happen in the feature engineering, okay? Sometimes you are engineer some features or extract some feature from the whole data set, okay? Even the test data set, you extract from the train and test with, yani, as well, yani, as a whole, okay? Then you apply it to the train, apply it to the test, this feature engineering idea. But I mean, it's too much information here, but generally know that as much as possible, the train and test should be and separate from each other, okay? Whatever information from the test you are leaking in the train, it will affect the training. It will give you a model. Maybe you will get super good results because you are training and testing on the same thing, okay? So it's your problem, your responsibility to ensure that there is no leakage. And the split is يعني went properly, okay? We will discuss this غالبا in detail maybe in the next lecture, and that's why actually we have too many types of splits. Train test split, we have k-fold, we have stratified k-fold, we have a lot of things, okay? So, okay, this is the duplicate. Fun thing is that in pandas, you just put the dataset and put duplicates. Okay, duplicate. This will tell you the amount of duplicates you have. You can just sum them. Okay, but if you want to drop the duplicates, it's dead simple here. Just pick the dataset, drop duplicates. Okay, and in place equal true, and yeah, call it a day. Okay, so but when we try to sum the duplicates, we find that there is zero duplicates in this, so we are going good. Yeah. Okay, this is the same thing I previously, but we are just here. يعني in this EDA part we are drawing or يعني the figures يعني the values of these features. Okay, so there's an important thing here I want to explain is that survival distribution. It's like the survival is actually our target. Okay, and when you do AI, we said that based on the other features we want to predict something. What is this thing that we want to predict? Is the survived, whether this guy survived or not. Okay, so this is our target. Okay, and this actually the most important figure here. Why it matters? It tells you something called imbalance. Okay, with the classes you have, the classes you want to predict, whether they are balanced or not. Okay, if these classes are not balanced, yani imbalanced data, we call this imbalanced target or imbalanced data. If you have such a thing, this actually has a lot of implications. Okay, has a lot of implications, not one implication, a lot of implications. Okay, and but if they are fairly equal to each other, okay, then you can do everything normally. Okay, but what actually matter if you have imbalance, you remember the accuracy, the metric we are using. We said that we use the accuracy, right? Actually, if you have imbalanced data, you should not use the accuracy. Okay, we will discuss this maybe when we discuss the metrics in the next lecture. But يعني it's something like if you have imbalanced data, okay, imagine like this. Imagine that this green one is just 5 samples, only 5 samples. Okay, and this red is just here like 600 samples. Okay, imagine I didn't build an AI model. I didn't build an AI model and just put a simple function that actually just return 0, return all of them died. Okay, so what accuracy are you getting? Accuracy is actually the amount of samples you classified correctly, okay, divided by the total amount of samples. So if I didn't build a model at all and just use all of them as 0, okay, so and oh my god, I have 600 samples here and I have only 2 or 3 samples here. Okay, so you are actually getting most of the set correct and you will get accuracy almost 99%. Okay, without even a model. You are just assuming all of them actually died. Okay, so who will tell you if your model is actually good or not? How will you actually evaluate your model? Okay, so the accuracy, if you have imbalanced data, the accuracy is not a good option. There are other metrics, something called F1 score, something called precision, something called recall. We'll discuss them later. But if you have imbalanced data, actually the metric you are choosing actually might change. Okay, other thing is that if the actually data is imbalanced, the way we split the data actually changes. Okay, there's the trend test split, there's the k-fold. These are random splits, we call them random splits. There's something called stratified split. Okay, stratified split is like something that ensures that the ratios of the trend test, yani of the classes in the trend test, are actually the same. It's not important here, but know that we actually look into the target distribution, whether there is imbalance or not, and based on that we will decide the metric. We will decide we will also decide the split. How do you split the data? And yeah, there are some other things. Okay, but this imbalance is important. So what we are saying is that not a very severe imbalance. Yeah, it's not that bad, خلاص. But you will find that, for example, in the medical image, mostly in the medical data, there's huge imbalance. You'll find, for example, only we have 100 samples are as ones and 900 samples as zeros. Okay, so such things actually matters in such data sets. So that's why actually EDA matters. Okay, you should get some insights in order to know what settings you should use for your training. Okay, so it's clear. This is just the distribution of the target. There is the age distribution. We previously said there is some outliers. You can see that there are some outliers here in the 80. Should I remove them or not? It actually depends on the score you are getting. You should keep them at the beginning, run your model, get accuracy, okay? Then go back, remove them, okay? And just go then rerun the model. Whether you get better results or not, based on that, you will decide whether you should remove the outliers or not. Okay. So we are just here seeing the how our data look like. Okay, we can see that the passenger class distribution, we mentioned that there are 3 classes. So most likely this class is the guest class, and maybe these are the business or something. Yani, I don't know. Okay, so these are the classes. And by the way, when I say imbalance, imbalance actually matters only in the target, in the something we are predicting. Okay, it doesn't matter in the features. This is a feature. It doesn't matter if you have imbalance here or not, but it actually matters a lot in the target only. Okay. So yeah, it's not that important here. We have the gender. We have 64% against 35%. It's a new function, a new function from matplotlib. They have the pi. Okay, you can draw anything here actually. So yeah, you can GPT it actually. No one saves this thing. Just maybe you want to understand just the arguments they are using. Okay. There's the encoding. As I mentioned, we should encode the features we have, as we should convert everything into numerical format. Okay, so we have this data set. These are the columns, the categorical columns we have. We should encode all of them. So how should I encode all of them? If you remember, we have something called dictionary, right? In dictionary, we have key and value. So imagine like I go through all the unique values of each column, okay, and give it a number. Yani here in part we have S, C, and Q. There are 3 categories. Okay, 3 categories. So why not define a dictionary like this? S 0. Okay. C 1. Okay. And Q 2. Yeah, we have such mapping or such dictionary. Okay. So why not just take this dictionary and apply it on this column? Okay, and call it a day. خلاص كده كده it's like this. We already converted this column into numerical. Okay. Now imagine that we have not only 3 categories or 3 classes in this column. Maybe you have 100 classes. Okay, maybe you have 100 classes. Would you define it like this? 100 samples, 100 keys. It's a bit too much, right? So can we automate this? Yani, could you have a function that actually we just give it the columns and it give a number to each unique value? So this is label encoder. This is label encoder. Okay. So in label encoder, you actually just give it the column and it returns you the column encoded. Okay, it returns the column for you encoded. So in this part here, we just do some fancy stuff to check in each column how many unique values we have. Okay, you can see that in this he printed here 6, we have 2, in bulk you have 3, the name we have 891. 891, and all the samples actually are 891. Okay, that tells you that each guy has a separate name. Okay, that tells you that the name is actually useless. You should drop it. Okay, the ticket is actually, oh my god, 681 ticket. That could tells you another thing. That tells you that some guys actually brought their families. So maybe the whole family is actually has only 1 ticket. Okay, maybe. Who knows? Okay. But anyway, if you want to encode something, just literally, okay, memorize this button in most of the Scikit-learn stuff you will do and AI you will do. You should firstly define something. You should fit it. Okay. You should either apply it to the dataset, apply it to something. Okay. So if you want to apply it, either you will use something called transform or predict. Okay. Just memorize this button. Basically, you will define something, fit it, either transform or predict. Transform if it's a pre-processing. Predict if it's a model, an AI model. Okay. So in an AI model, you will define the model, you will train the model using fit, then you will use the model to predict on new data. Okay. Use the trained model to predict on new data. But in pre-processing, you will define, okay, you will define the pre-processing you want, like here, label encoder. We defined it. But where we brought this name, we just use it. Okay. If you remember in the top, we use this one, صح? Pre-processing, import label encoder, right? So we already imported from the library. We defined it here. Okay. Then we should fit to make it learn the dictionary. You remember the dictionary I wrote here, this one? So fit means for the encoder, please learn this dictionary. Okay. Then transforms means please apply this dictionary. Okay. Apply this dictionary on a dataset I will give you. So here we define the label encoder. It turns out in Scikit-learn, they make your life a bit easier. Okay. So why not fit and transform in the same line? I can do it in 2 lines, but يعني let's do in one line, okay? And I give it the column, for example, the 6, okay? And it returns the column encoded, okay? With 0 and 1. You can see it here. Previously, it was male and female, okay? And then after here, it is said as 0 and 1, okay? So I can just put a loop here and pass all the categorical columns in order to يعني convert all of them into categorical, okay? Something like this يعني, okay? يعني for column in yeah, he already wrote it here. For column in these columns, you can see it here at the top. For all of these column, I want you to define the label encoder each time, يعني reinitialize it, okay? And I want to feed, okay, the dataset with this column يعني. I want you to learn the mapping, learn the dictionary, apply the mapping on this categorical column, and return the converted column or encoded column and just put it in the dataset. So this line, actually, this lines should convert all of these columns into encoded columns. Okay, hope it's clear. So yeah, this is the encoder. We have label encoder, which actually gives each category just a number. Okay, this is one type. It's the mostly used type. Mostly used type. There's something called one hot encoder. Okay, it's basically instead of giving convert text to numerical values, yeah, label encoder convert text to numerical values. It gives each unique value. Yani, for example, we have the impact. We said we have S, C, and Q. Okay, so 0, 1, and 2. So it will be 0, 1, 0, 0, 0, 0, 0, 0, 1, 2. Okay, so it will convert everything into numerical values. Come on. There's one hot encoder. Okay, it actually converts things to numbers, but in a different way. And instead of actually giving each value a number, okay, let's expand the categorical, yani the unique values into columns, okay? So instead of going to this impact and give this 0, 1, 0, 0, 0, 0, 0, 0, 1, 2, let's remove this column, remove this impact column at all, and let's add 3 columns, okay? Column called embarked S, embarked C, and embarked Q, okay? And make them binary, 0, 1, 0, 1, 0, 1, okay? Whether this is actually S or not, whether this is actually C or not, whether this is actually Q or not, okay? So it's like it expands the unique values into columns, okay? And all of these columns actually binary. So to figure out يعني they are binary, so you can يعني it actually يعني still it converted to numerical, but it adds actually more columns. So what is the advantage of this and disadvantage of this one hot encoder? And label encoder as well. Label encoder is actually that easy, okay? And it get inputted with one column and gives you one column. Okay, this is good. Okay, we don't increase the dimensionality, we don't increase the features. Okay, but in one hot encoder, we give it one column and it gives us 3 columns. طيب, imagine the unique values are actually too much, maybe 20 or 30. So for each one column, we got 20 new columns. Actually, the more columns you have here, most likely the worse your results in the model. Okay, this is called yani curse of dimensionality. Okay, if you have too much features, this might actually degrade the performance of your model. So one hot encoder actually has an advantage, a disadvantage of يعني it increases the dimensionality a lot. It increases the number of features a lot. Okay, so but it has another advantage. What is the advantage is that if you see here, we give this 0, we give this 1, and we give this 2. Okay, so the model, when he look into this column, we see 0, 1, 2. He don't know what is the meaning of 0, what is the meaning of 1, what is the meaning of 2. He just see 0, 1, and 2. Okay, so when he sees 0, 1, and 2, he will believe that 0 is the first, 1 is the second, 2 is the third. Okay, but maybe 0 is actually the guest class. Okay, and maybe 1 is the first class and 2 is the business class, which is lower than the first class. Okay, so does that make sense? 0, 1, 2 business first guest, business guest first business. يعني the model will look into the order. The model will look into the order. So one disadvantage of the label encoder, if the order, okay, doesn't make sense, then most likely, I don't say it will degrade the performance. Yeah, it's a baseline. You can just try it at the beginning and see if the result then change later. But if you have order in the column, label encoder might work better. Okay, but if you don't have an order in the column, okay, and you use label encoder, maybe, okay, the model will take these numbers as order and consider them as signal and might give you worse results. So in such case, maybe one-hot encoder would work better. Okay, but the problem of one-hot encoder is too much columns, which is actually really bad, really bad. Okay, that's why most likely you will see just label encoder, label encoder. And label encoder and call it a day. Okay, so. And we, as we see here, we drop the column name ticket in bulk. We, as we mentioned before, we can drop them. This is the feature scaling, as I mentioned. The standard scaler do Z score, and min max scaler just convert to 0 and 1. Okay, this is the mean and standard deviation. So the same actually concept as I mentioned before. Define it. We already imported it from Scikit-learn. Okay, so define it here. Fit transform the data. Each time give it a column, and it will return you the column scaled. Okay, scaled means actually it's been normalized, or Z score has been applied, or min max has been applied. Okay, but exactly the same button. Define it, fit it, transform it. Okay, he plots some of what happens. You can see that before scaling, the mean is 29, standard deviation is 13, minimum 80, right? But after scaling, the minimum is -2 and the maximum is 3. Okay, the mean is almost 0. This is طبعا notice here -16. -16 mean 10 to the power of -16, which means that 0.000000000 لحد 16. Okay, then 2272. Okay, so almost 0, almost 0. Okay, so what happens is that it actually scaled the values to some other range. Okay, so wait a minute, we are talking about age. Okay, and we scaled the age from its normal values into someone whose age actually -2. الله المستعان ايش هذا. خلاص. ف does it matter? Does it change anything? For us as human, it changes a lot. It changes the meaning for us as human. Okay, but for the model, it doesn't change anything. It actually makes it better because you are making the range of the columns close to each other. Okay, why it doesn't matter? Because for the model, because the histogram is the same, the distribution is the same. You see that the distribution is exactly the same. What changes is only the x-axis. Notice the x-axis in the edge left and the edge on the right. Okay, but the distribution is the same. Same for the fair, the exactly same distribution, only just the values in the x-axis which change. As long as the distribution didn't change, it doesn't matter for the model. It will work. Okay, so but it will confuse us as a human. This guy is age -2 or something. Anyway, so these are the scaling. Okay, such a data set, actually, after all these steps, we already dropped the columns that are useless, we encoded everything, we filled the missing values, we scaled everything. This, if I were to do a next step here, okay, I will just define the machine learning model, fit the machine learning model, and predict with new data. Okay, طبعا before that I'll split into train and test. But this is for another topic. But that's it. That's a very simple pre-processing. Okay, actually pre-processing differ between the type of the data. Here we are talking about this called tabular data. Okay, there are something called time series data. There's something called the images. The image actually has different pre-processing. Okay, how to pre-process it has some different ideas. The text, actually, it's actually also has some different things. The audio, okay, it actually matters. So it depends on the data, how would you pre-process it? And each one has best practices. Okay, and similar to how you do the intuition now, this actually transfer to the other domains. The text and the image, each one has some intuition that you will use based on it to decide the pre-processing you are doing. Okay, and this is the exercise. That's it. I should think I did consensus. It contains a lot of problems. You can see he even encoded the missing values as question mark rather than nan. So one thing you should replace this question mark with nan, then fill na. Okay, and you should convert each of these one into to numbers. Okay, you should do scaling. You can see 4,000 here or something. Okay, so I think that's it. If you have any questions, Why it only scaling age and fair? Yeah, because these are the numerical columns, okay? We scale the numerical columns. We don't care about the categorical columns, okay? Because categorical columns are already, yani, we convert them in with the encoding into 0, 1, 2, 3, so small values, okay? But we usually scale the continuous values, okay? The numerical values, okay? But ايوه I got it. لكن خليني اعطيك معلومة زيادة خلاص. But when you do encoding, okay, you actually converted the categorical features into numerical features, okay? So you are correct. We should scale all the features we input to the model, okay? Not only the numerical features. The one we encode, we should actually scale them as well, okay? Uh, so this is just important, يعني. What is a good question? Any other questions? Uh, Actually, I want to let's let you see last thing. Yani, where should you get such data if you were to practice? There's something called Kaggle. Okay. If you have several columns, categorical columns, should you use the label encoder several times or one hot? Actually, if you have several categorical columns, you just put a loop. Okay. For column in, put the list of the categorical columns. Okay. Then inside the loop, define the label encoder, define label encoder. In the next line, fit, transform, dataset, put the column name. So you are fitting on this column in the current iteration, in the current loop, okay? Transform it. Yani, then in each iteration, you will process one of the columns, okay? In terms of one hot, as I mentioned, I just told you the advantages and disadvantages, but what actually better depends on your data set, depends on the results you are getting, okay? So you should try these options and see how the accuracy actually goes up or down, okay? There are some intuition, but most likely you should try them in order to figure out, yani, okay? So I just want you to tell you last thing is that Kaggle is actually the largest community AI. You can go to the dataset part. You'll find a huge amount of datasets here, okay? Any type of dataset you can think about, you mostly will find it here. Trading data, Tesla global deliveries, Madinah, climate change data, I don't know, secure water meme. خلاص. You'll find all amount of all types of data you can think about. You'll find it in Kaggle. Whether they are image, whether they are audio, NLP, do you want it for visualization, okay? And for some or maybe many of these datasets, like this living data, you will see a description of the dataset here. The dataset itself will find it here. For example, this dataset, you can see it contains several things here, okay? These are the columns it has. This is some descriptions. And nice thing, you will find something called code here. Do you see it? Code. It means that some people in Kaggle went to this data, yani took it, okay, and tried to do yani some work on it, okay? As you can see, sleep prediction, sleep data cleaning, okay? Use some models called XGBoost. So you can see that these are actually, all of these are notebooks, okay? So if we went into this data cleaning, no one said it looks the best thing, but you can see people try to do pre-processing, okay? So you see the same thing we did before. See here, missing values, too much missing values. It's just a very short thing. Yani, these are not the good ones. Sometimes you'll find actually notebooks that are super good, okay? Especially if the dataset itself is actually highly rated. So if you enter into, for example, attendance set and yani most votes, okay? So we sorted based on the most votes to look at the top. So these are so small. All datasets, yeah. All datasets, most votes. ما شاء الله 55,000 يا لطيف. خلاص, if you just entertain this one, look into the code 107. Okay, and even here, let's write it by most votes, okay. uh yeah, you have cheat sheet, ما ادري ايش يقول. You'll find a lot of notebooks that does analysis, that does actually predictions. So شوف it's very مرتبة يعني. خلاص, histogram on density, okay. You see, so much analysis is done here, okay? And sometimes you'll find models actually trained and used to predict something here, okay? So if you want to practice, you can do that on the datasets class, okay? And there are actually even the competitions, okay? And the competitions is actually part of the, yeah, maybe the best part in Kaggle, is that in these competitions, they actually give you a data set, okay? And they split it into train and test. They give you the train here, okay? Yeah, and you can see it here, the training data, they are giving it to you. with the target. They give you the target, okay? And they give you test data, but without a target, okay? So you should train on this training data, okay? Predict the target for the test data using a machine learning model or AI model, and then pick these predictions, okay, and submit them to the competition in order to join the leaderboard, okay? So it's like an international competition where everyone try to build the highest accuracy model, okay? So wallahi, it's not that easy, but wallahi, it's very addicting and fun, yani, okay? You'll see a lot of people in the discussion actually discussing about the problems, how should we split the data, how the data was generated, possible bug in the evaluation metric, and then you'll find so much fun here, okay? And in the code, in all of these competitions, most likely you'll find ready code, okay? This is actually code that actually does the, yani, everything from the data analysis, building the model, making prediction, submitting to the leaderboard, okay? But the result is not the best. So it's like a baseline, something you can start with, then you can improve upon it. Yani, for example, this is 57, okay? But the leaderboard here is we're talking about 73, 70, 69. So you have to do a lot of work in order to get to this extent. And it has some medals, and yani, it's very fun. And after each competition, you will find that the top guys in the leaderboard will actually reveal their solutions, actually, which is very useful. I actually learned quite a lot just from participating in these competitions. So it's just a fun thing. Yani, try to go through Kaggle. You will have fun. Something related to biology, something related to, I guess, NFL, I think it's the basketball or something like, related to, I guess, even the commodity, something related to, I don't know, mice prediction, action recognition. I mean, no one said they are easy, okay? Just to be clear, يعني super clear here. No one said they are easy, especially with these nice prizes, يعني. Uh, like in, if you actually improved your skill, okay, and to the extent you can participate in these ones and spend good amount of time, you will get very skilled in AI, inshallah. Okay. So there's competitions, there is the data sets, there is something called code here. Okay. And one nice thing is that in Kaggle you will find explanation for anything you want. Okay. So imagine you want an explanation now for I don't know. I told you there's something called time series, صح? Time series, I don't know, introduction or something. Okay. Introduction to time series clustering, introduction to time series analysis, okay, exercises, so you'll find actually tutorials and labs for everything you want to understand, okay? So it's not about just taking data and doing work analysis on them. You will find a lot of things that you can utilize in order to actually learn, okay? Some learning stuff. See, here he is actually literally explaining all the concepts of time series, okay? How to import the data, how to, we have some specific missing values idea, and yani, you can see it's really fun and useful, okay? And you can see there's a part here called Learn. It has some mini courses, okay? For some parts of the AI, maybe you can go through them. It's just fun. Maybe this data cleaning part, this Python part, okay? It's easy, as this is very basic, but yani, is good just to give you some intuition about everything happens. Uh, but yeah, I want to introduce you to Kaggle because I think it's the main part of your learning journey. If you want to get any data set, if you want to learn something, if you want to practice, most likely you will get some data set from here and try to do work on it. Okay. So yeah, that's it. Thank you.